Dear student, welcome you all to my YouTube channel Learning Island. Today I am here with you with the topics of concise physics class 10. So here I will discuss basically the solution for the numericals exercise wise. This is video number 1. Then you will get video number 2 on 8b and then 8c, video number 3, so on. So you will get all the solution for the numericals physics one by one if you go through my videos. Now here one thing I have to mention, that for every chapter, to clarify the basic fundamentals, I have made separate video naming as basic fundamentals and explanation. Before going to the numericals, you can go through, you can watch my video on fundamentals. The links of this fundamentals video is given to the description. So let us start the numericals, chapter 8, exercise 8a. So this is the first numerical. It is given that in a conductor 6.25 into 10 to the power 16 electrons flow from its end A to B in 2 seconds. Find the current flowing through the conductor when E equal to the charge of one electron is given 1.6 into 10 to the power minus 19 coulomb. We know that. So what is that? You see, there is a conductor. Suppose this is a conductor. Okay. So the current, this is terminal A, this is terminal B. Current starts flowing from A to B, current I. So we'll have to find out the current. The another data given is N equal to number of electron flow. This is given. This is equal to 6.25 into 10 to the power 16, and also E is given, E equal to 1.6 into 10 to the power minus 19 coulomb. E is the charge of one electron. So you see, what will be the total charge? Number of electrons into charge of one electrons, that is N into E. So the time is given, time T equal to 2 seconds. So if you watch my fundamentals video on these topics, you will find that a derivation, a formula, I equal to Q by T, that is Q here is the total charges in coulomb by time. So the charge flow per second is called the current. So this is equal to, and Q is equal to number of electron into charge of one electron, it is E by T. Here N equal to 6.25 into 10 to the power 16 and E equal to 1.6 into 10 to the power minus 19. So if the time is 2 seconds. So if I
make the simplification. 2, if I cut 2, this will come 0.8. So finally I am getting 6.25 into 0.8 into 10 to the power, here you see 16 plus and 19 minus, so it will be minus 3. So finally the unit will be ampere. So if I multiply it further, I will get 5 8s are 40, carry 4, 8 2s are 16, plus 4 20, carry 2, 6 8s are 48, so 50. The point is here 5 into 10 to the power minus 3 ampere. So it will be equal to 5 milliampere. So the amount of current is 5 milliampere. So hope you understand this. So please find the final solution over here in the next page. Yeah, so this is the final solution. So you can write it down. Here it is written. So let us go to the next question. This question number 2. Question number 2 is written over here. A current of 1.6 milliampere flow through a conductor. So first of all, always you write down the given data. Then you will find, the solution is very easy. So what is given? Given current I equal to 1.6 milliampere. So take it into ampere. 1.6 into 10 to the power minus 3 ampere. And what is given more? The charge of one electron is 1.6 into 10 to the power minus 19 coulomb. Find the number of electrons that will pass each second. So time t equal to 1 second. I will have to find out the number of electrons. So let number of electron equal to n. So again the same formula I can apply. I equal to n e by time. So you see I is given, it is 1.6 into 10 to the power minus 3 ampere, and it will be equal to n into electron E is 1.6 into 10 to the power minus 19 divided by 1 second, because time is 1 second. So if I simplify it, I can get n equal to 1.6 into 10 to the power minus 3 divided by 1.6 into 10 to the power minus 19. So if I cut it, 1.6 by 1.6 is cancelled. So finally I am getting 10 to the power minus 3 plus 190. So it is 10 to the power 16. So the number of electrons is 10 to the power 16. This is the final answer. Hope it is clear to you. Now just write it down. This is the final solution in written. So hope you are getting me very easily. Go to the next. So this is the question number 3. Find the potential difference required to flow a current of 200 milliampere in a wire of resistance 20 ohm. So here you see in a conductor current flowing is given. I equal to, is it given? Yeah, current flow I equal to 200 milliampere, यानी कि this is equal to 200 into 10 to the power minus 3 ampere.
this is the given data. So I always suggest you to write the given data first, then the solution is very easy. So this is I is given, and the resistance of the conductor, resistance which I denoted by R, is equal to 20 ohm. So from the Ohm's principle, we know the Ohm's principle is V equal to IR. So here V equal to the potential difference between 2 points of the conductor. So we will have to find out the V. So we know I. So we put here I is 200 into 10 to the power minus 3. R is 20. So the finally on simplification we get 400 into 10 to the power minus 3 volt, because the unit of potential difference is volt. So here I am getting 4 volt. So this is the solution. So let us, you can note down it by pausing the videos. So I am going to the next question. This is question number 4. An electric bulb draws 1.2 ampere current. So given the current I equal to 1.2 ampere at a voltage, so V is given 6.0 volt. Find the resistance. So resistance R equal to what? So it is again apply the Ohm's law. V equal to IR. It is very easy. So R will be equal to V by I. So that is V is here 6 and I is 1.2. So if I simplify it, if I omit the decimal point, so 10 will become in the numerator. So 6 2 za 2 5 za. So this is 5 ohm. So answer is the resistance of the filament of the bulb while glowing will be 5 ohm. So this is the solution in one page. So please write it down again. Now question number 5. Here you see a car bulb connected to a 12 volt battery. So here given V equal to 12 volt and it draws 2 ampere current when glowing. So I equal to 2 ampere. What is the resistance of the filament of the bulb? So R is what? So again by applying Ohm's principle, Ohm's law, you can say. So this will be V equal to I into R. So R will be equal to V by I. So again put the data. V is 12 volt, I is 2 ampere, so I am getting 6 ohm. Again it is mentioned that will the resistance be more, same or loss when the bulb is not glowing? Yes, when the bulb is not glowing, the resistance will be less. Why? Because as you know that the resistance of a conductor depends on the temperature or the heat, how much the conductors get heated up. So if the bulb starts glowing, that means it is getting heated up, so the resistance will be more. So when it is not glowing, just at the beginning, the resistance will be less. So this is the final solution. You just pause it and write it down. The basic importance of this class is to understand the basics of all these numericals. So I think the numericals are very easy and you are getting understand. So let's go to the next. This is question number 6. In question number 6, it is mentioned that calculate the current flow. That means what is given? Current equal to what? We will have to find out it. And the resistance R is given. How much? 5 ohm. You know the symbol of ohm is this. Connected to battery. That is the voltage is also given. Voltage V equal to 3 volt. So we have to find out the current. So again Ohm's principle is very simple. Ohm's principle V equal to IR. So I will be equal to V by R. So V is 3 volt and R is 5 ohm. So it will come 0.6 ampere. So this is the answer. Very simple. So go to the solution, final solution. Then go to the question number 6. So question number 6, the given, here you find a chart that some data are given. In an experiment of verification of Ohm's law, the following observations are obtained. In a tabular form, it is potential difference in voltage given 0.5, 1.5 volt to 2 volt and 2.5 volt. So the corresponding currents are 0.2 ampere, 4.4 ampere, 0.6 ampere and 0.8 ampere and 1 ampere. This is the observation. Now we are asked to draw a characteristic VI graph and use this graph to find out the following data. So let us first of all draw the graphs. So here it is mentioned VI graph. So VI means, so V is given in the left side, I is right side. So V will be in the vertical direction on the graph paper and I will be in the horizontal direction. So let us draw the graph first. So I am going to draw the graph here like this. So I am taking this as the lines are not getting so straight, whatever, if you do it by scale. So this is X in X direction and this is Y direction. So in X directions I will have to take I. So this is I and in Y direction I will take B. So that's why it is VI graph. So if it was asked IB graphs, then we will have to take I in the vertical direction y-axis and V in the x-axis. As it is mentioned that this is a VI graph, so V will be in the vertical axis, that is y-axis, and I will be in the horizontal axis. So if I take this is as 0.2, this is 0.4, this is 0.6, this is 0.8, this is 0.1, and here also this is 0.5, this is 1.0, this is 1.5, 2.0 and 2.5. That is, the scale will be like this. Scale will be like this in vertical axis, in y-axis we have taken 5 square equal to 0.5 unit. and in x-axis we have taken 5 square equal to 0.2 unit. You'll have to mention this in the graph paper. Okay, so now let us draw this graph. How do you draw this graph? That is given 1.2, it is 0.5. When the current is 0.2, the voltage is 0.5. You can say when the voltage is 0.5, the current is, so this point, the point will be this. And when this is this point, when the current is 1, when the voltage is 1, the current is 0.4. So again I will get when the voltage is 1.5, current is 0.6. When the voltage is 2, the current is 0.8. When the voltage is 2.5, the current is this. So if I join these lines, we are getting this. Just a minute. Just a minute. Yeah, if we join this line, roughly it is coming like this. So now the graph is completed. Now the question is, when number A, potential difference B when the current I is 0.5 ampere. From the graph you can now find out the potential difference B in the vertical column, vertical direction. So the when current is 0.5, here see this 0.4, so 0.5 will be here. So if I go in these directions, and from here this line will touch here, so from here if I go in these directions, the point will come here in the middle. So that means it will come, because every 5 unit is representing 0.5, so every 1 unit representing 1, so that is 1.1, 1.2, that is 1.25. so this will be 1.25. so in A the answer will be 1.25 ampere. No, the volt, because when if the current I, when the potential difference is 0.75, so if I take the potential difference 0.75, here you see this is 5, 6, 7. So potential difference when it is 0.75, that is here, 5, 6, 7.5 is here, so it will come in these directions. If I draw the graph properly, you will get here. So I will get this is as 2.2 point, it will be 3.27. This is coming around here. So in the x-axis I have taken 0.5 as a 5 unit square is 0.2, so 1 will become what, 0.2 divided by 5, make 0.04. so it will be 1, 2, 3, will be 3 point something. So let us see the answer. Final answer is this. So yeah, it has been written clearly. So when the difference is current is 0.3 ampere, the differential is 0.75. Let us see, current is 0.3 ampere when the potential is 0.75. The graph is linear, and thus there is another question, I think. The resistance in the circuit. So what will be the resistance in the circuit? Resistance will be in the, if you divide this, any data the given from this data, here 0.5. If you divide 0.5 by 0.2, you'll get what? You'll get 2.5. So here the resistance will be 2.5 ohm. So hope this is clear to you. Now let us go to the question number 8. This is the last question of this video. So here it is mentioned that two wires of the same material and the same length have radius 1 millimeter and 2 millimeter respectively. Compare their resistance and their specific resistance. Two wires of the same material, yani ki the you see the same material of radius. Suppose this is wire, this is another wire which is a little bit thick. Okay, both of these are same material, that means rho 1, that is resistivity, and rho 2 will be equal, and the radius of this cross section, if it is r1, and this is also the cross sectional area of the wire, if this radius is r2, if this is r2, so and 1 millimeter radius, and so r1 is 1 millimeter, and so it will be 1 into 10 to the power minus 3 meter. Here r2 is equal to 2 millimeter, that is 2 into 10 to the power minus 3 meter. So and two wires of the same material and same length, here length L1 equal to also L2. So what will be their ratio of the resistance? So we know we have a formula, that is R1 equal to, formula is R equal to rho L by A, where rho is the resistivity of the material and L is the length of the material, it is wire, and the A is the cross sectional area. So here I can write rho 1 L1 by A1, and R2 will be rho 2 L2 by A2. So this is number 1, this is number 2. If I divide number 1 by number 2, we'll get R1 by R2 equal to this rho L1 by A1 rho 2 L2 by A2. Here you know the rho equal to rho1 equal to rho 2, L1 equal to L2, so I can write rho L by A1 rho L by A2. Rho cancel, so I will get A2 by A1. So if I put the formula, A2 is pi R1 R2 square, here also pi R1 square, pi cancel, I am getting R2 by R1 whole square. So if I put the values, 2 into 10 to the power minus 3, here 1 into 10 to the power minus 3, whole square. So I will get 4. So that means R1 is to R2 will be 4 is to 1. That means the resistance will be 4 times. So again it is mentioned that what is the specific resistance? As the materials are same, so the specific resistance, the ratio of the specific resistance, the resistivity will be 1 is to 1. So I hope this is understandable to all of you. So now go to the final solutions. This is the final solution. Here I have already mentioned you the radius is R1 for the one conductor and R2 for the second conductor, and rho is the resistivity. Here it is rho for same for both the conductors. L also same for both conductors. So finally we have got this 4 is to 1 here. So this is this will be equal to 4 is to 1, and the ratio of the rho 1 and rho 2, that is the resistivity or the specific resistance, will be 1 is to 1. I hope this is clear to all of you. If you feel really beneficial from this video, please subscribe my channel and press the bell icon so that you can get all my notification of my coming videos on these topics. And also please share this video to your friends so that they can also get the benefit out of this video. So thank you all for remaining with me during this whole session. Thank you again, and bye bye. I'll meet you in the next video. Bye.